In this section, we're going to solve a few more logarithmic equations and then also look at what's called change of base. Here's our first equation. Let's solve 3 to the x is equal to 5. Logarithms are very helpful with a problem like this because our variable appears as an exponent. And I know logarithms make exponents into coefficients. So I'm going to take log base 10 of both sides of this equation. So log base 10 of 3 to the x is equal to log base 10 of 5. So if these two numbers are equal, then their logarithms base 10 are equal also. Next, I'm going to take this exponent and make it a coefficient using my property of logarithms that says that I can do that. Now, isn't that nice? Here I had x as an exponent, now it's a coefficient. Remember, this log 3 is just a single number, so to solve this equation, I'll just divide both sides by log 3, and I'll end up with x equals logarithm base 10 of 5 divided by logarithm base 10 of 3. That's the exact solution right there. If I want, I can go to my calculator, find log 5, divide that by log 3, and get a decimal approximation to this of 1.46. You may want to try that yourself just to see if you get the same result. Okay, so 3 to the x is equal to 5. I want to take this exponent right here and make it a coefficient. I can do that by taking the log of both sides. Apply property 3 for logarithms. That exponent becomes a coefficient. Divide both sides by log 3. I end up with a nice quotient right here. I have an exact value, and then using my calculator, I have an approximate value. Here's another one. 3 to the 2x plus 1 is equal to 2. I'll do the same thing and take log base 10 of both sides. So log base 10 of 3 to the 2x plus 1, log base 10 of 2. I'm going to take this whole exponent right here and move it out as a coefficient using property 3 for logarithms. So I have 2x plus 1 times the log of 3 is equal to the log of 2. Now at this point, there's a lot of different ways to go through here and solve for x. I'll show you the way that I like to do it. There's other ways to do it too, but let me show you my way first. I'm just going to take this coefficient log 3 right here and divide both sides by it. When I do that, I have 2x plus 1 is equal to log 2 divided by log 3. So I do that. Next, I'm going to subtract 1 from both sides. 2x is equal to log 2 over log 3 minus 1. Okay, so I want to solve this for x. I'll multiply both sides by 1/2, and I have x is equal to 1/2 times the quantity log 2 divided by log 3 minus 1. So this is the exact value right here. I can find an approximate value by going to my calculator, put in log 2, divide that by log 3, subtract 1 from that, take that whole thing and multiply by 0.5, and you'll get a decimal approximation for x. The main point of this problem is, though, that if you take the logarithm of both sides right here and your variable appears as an exponent, you can move that exponent out in front and make it a coefficient using that property 3 for logarithms. Here's one more problem. We have 4 to the x plus 1 is equal to 4. Now, we don't want to forget with all our fancy properties and things here that there's some problems that are still easier to solve without logarithms. And I know by looking at this equation that 4 to the first power is going to give me 4. That means that this exponent, x plus 1, has to be the number 1. So x plus 1 has to be 1. I'll add negative 1 to both sides. X has to be 0. So the only way 4 to the x plus 1 can be equal to 4 is if x is equal to 0. So I have 0 plus 1 is 1. 4 to the 1 is equal to 4. So that's a problem that's very simple to solve without using logarithms, although logarithms will work with it also. Let's look at some change of base problems. I have log base 8 of 16. I want to evaluate this. I have no button on my calculator for logarithms base 8. So I'm going to have to change into something I have a button for on my calculator. That would be logarithms base 10. My change of base property says that log base 8 of 16 can be written as log base whatever we want, in this case 10 of 16, divided by log of the same base of 8. So don't forget we're using log base 10 here in both cases. Now I put this in on the calculator, do the work, it ends up to be 1.33, and it just continues like that. So what's that, 4/3 1 1/3. Log base 10 of 16 divided by log base 10 of 8. So even though I don't have a log base 8 button on my calculator, I can still use my calculator to find logarithms any base. Here's another one. Log base 7 of 15. Okay, that's going to be log base 10 of 15 divided by log base 10 of 7, using my change of base property right there. And then I'm going to go and look that up on the calculator. Let's see, I'll move it down here. That comes out to be on the calculator, I think, 1.39. Let me just check. If I round that off, yeah, 1.39. So I just press my base 10 logarithm on the calculator of 15. Same thing for 7. Log 15 divided by log 7, 1.39. So there's a look at some equations that we solve using logarithms, and then also our change of base property.